Today we are going to discuss about the phenomenon of electromagnetic induction. What is this electromagnetic induction? In short form it is called as EM induction. Before the early stages of the 19th century, most of the scientists and everyone thought that electric fields and magnetic fields both are separate. Before 19th century, electric field and magnetic field both are separated. That is their assumption, not true. But in the early ages or early years of the 19th century, Mr. Oersted, he is the scientist, great scientist. He observed an accidental observation. What is that accidental observation? He placed one compass box needle like this. This is a magnetic compass box which is placed near to a current carrying wire accidentally, unexpectedly. Means after doing some experiment, he just placed. Whenever this is a current carrying conductor, okay, like this, then he observed this magnetic compass box needle, it is simply vibrating or oscillating. And he moved this compass needle away from the current carrying conductor, then the deflections are reduced and the needle initially within a quick time it is coming to the rest position. So what is his observation? He concluded that a current carrying conducting wire produces a magnetic field. A current carrying conducting wire produces a magnetic field. Because of that only this magnetic compass needle is simply vibrating or oscillating. This theorem, this statement, later years it will become like this. A current or electric field which is varying with time or a varying electric field can produce a magnetic field. A time varying electric field can produce or easily produces magnetic field. This is the observation by the Oersted, a great scientist. Then later, very next years of this discovery, most of the scientists including Oersted thought like this: the converse effect also true or not? Converse effect means here time varying electric field is producing the magnetic field. Converse effect means a time varying magnetic field can produce the electric field or not. Most of the scientists thought about converse of this effect. What is the meaning of converse effect? A magnetic field, time varying magnetic field can produce electric field or not. But among them, Faraday, one of the great scientists, Michael Faraday, he was succeeded to prove the converse effect is true. And what is the experimental setup of him and what are the conclusions he made with respect to this induction phenomena. Now we are going to observe some experiments which are did by Faraday and Henry to prove the electromagnetic induction. The experiments did by Faraday and Mr. Henry These two scientists did the experiments to check the converse effect of the E to M, means electric field to magnetic field. So for that purpose, they took one coil like this. The two ends of the coil connected to galvanometer. There is a coil. In our textbook, it is given like a rounded shape. So it is very difficult to draw this rounded shape diagram in this 2D shape board. That's why let us assume the coil like this, which has some n number of turns. Now this coil is simply connected to galvanometer. Galvanometer is able to sense the small amounts of the currents and the direction of the current. Now take a magnet. They took one magnet of north and south poles. What they did, initially this conducting coil which is connected to the galvanometer and this magnet are separated by a finite distance. Now what they did, they moved this magnet towards the coil. Whenever the magnet which is at long distance, when it is moving towards the coil, what are the observations they experienced is, see this north pole which is acting like a high pole strength, south pole low pole strength. This north pole is able to attract the electrons which are inside the conducting loop. So therefore, it creates the magnetic flux like this. And this flux is able to attract the conducting electrons which is in the conducting loop. Then they observed the deflection of the galvanometer needle towards the north pole of the magnet. Now they removed this north pole to the long distance. Then this galvanometer needle moved to the opposite direction. They did the same experiment with interchanging the poles of the magnet, south and north. And they have observed the same deflections in the opposite order or in the reverse order. So this is the coil connected to the galvanometer. One magnet is at a finite distance, which is at a distance. No change in the galvanometer needle. Now this magnet is simply approaching towards the coil. Whenever it is approaching, and when they started to approach towards the coil, they have seen the deflections, and the deflection of the galvanometer is opposing the north pole of the magnet. Whenever they removed the north pole and moving the magnet away, then they observed the deflections in the opposite order, and while they interchanged the magnetic poles also, they have observed the deflections of the galvanometer in the reverse order. So this is one experiment did by Faraday and Henry with respect to magnet and coil. This experiment is also called self-induction experiment. Now, what is the reason for the deflection of the galvanometer needle in this experiment? Whenever the magnet is here, around the magnet we can expect a magnetic field. This magnetic field is nothing but a space surrounded around the magnet where another magnet can experience a magnetic force of attraction or repulsion. That is said to be magnetic field. Magnetic field is nothing but the content of the whole number of magnetic loops. That means this magnet is able to eject the magnetic field lines towards the conducting coil which is initially connected to the galvanometer. The number of field lines which is passing through unit surface area of the conducting body is said to be flux. The number of magnetic field lines passing through unit surface area of the body which is perpendicular to the plane is called magnetic flux. That means here some current is developed within the coil, and that current is able to oppose the magnetic flux, because flux direction is like this, galvanometer direction is also like this, which is opposing. This is the galvanometer deflection, this is flux. So what we can conclude from this experiment and what is the statement given by the Faraday and Henry after doing this experiment is a time varying magnetic field or the change in magnetic flux can create an induced EMF within the coil. A time varying magnetic field or change in magnetic flux produces an induced EMF in the coil. This is called electromagnetic induction. This phenomenon is called EM induction. They did the experiment with one magnet and one coil. Now they replaced the magnet with another coil. How that experiment and what is the result? We will see now.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.